We're going to be talking about DNS rebinding with pure Java applets. This is the agenda. I'm going to go over it very quickly and then just move on because I think we're running just a little bit short of time because of the previous presentation. That's perfectly fine. Some people ask me why we're doing this, and I think a lot of it kind of starts from this first little line up here that says, I prefer owning the server. And so I was talking to someone a couple months ago actually about cross-site scripting and various client-side exploits. And he made a very interesting comment to me. He said, you know what, cross-site scripting is really cool. It's all good in that. A lot of people like it. Cross-site request forgery, yeah, it's a big deal. But I'm not really into that. I prefer owning the server. And it kind of struck me. And he said, hey, if you can ever use cross-site scripting or some kind of client-side exploit to own a server, let me know. And then he hung up on, well, I actually closed the chat window. And I was like, oh. So that's what I've been working on for the last couple months, me and Nate actually. So we looked at a lot of different client-side technologies. And one trend that we realized amongst all client-side technologies is that they're becoming more and more powerful. So initially, these client-side technologies can only do limited things. Nowadays, it seems like a lot of the client-side technologies can do almost anything. And we're going to talk a little bit about that a little more and show you a little bit more about that later on. And the other thing that we also noticed is that a lot of people kind of adhere to what we call heavy doors with open windows. So what they have is this, stout firewall that's really good, and it's actually very good at what it's supposed to do. It's supposed to block traffic that's not supposed to come into an internal network. It's supposed to provide that segregation from the internet, which is hostile, and the internal network where everyone is trusted, right? So it actually does a very good job of doing this. The only problem is it's got holes. And the holes aren't there by default, or the holes aren't there on accident. People actually put these holes in there. And the biggest hole that we see is HTTP, Hypertext Transfer Protocol. Every single firewall that we've seen pretty much on a corporate perimeter allows this traffic to go in and out. And so instead of trying to kick down this very heavy door and trying to exploit this firewall, why not go through the window? They're going to open up this port for us anyway. Why not take advantage of this port and do some damage and maybe access a host on the local internal network or access a device or a network device that's on the internal network. We don't need to kick down the door, we just need to go through the window. And I guess the reason I think like this is because I used to be in the Marine Corps. They made us study warfare, and we had to read a lot of material from a guy named Sun Tzu, who wrote a book called Art of War, and he always talks about, hey, don't attack the enemy at their most strongest point. That's the firewall. You find some weakness, you find some hole, you go through the hole. That's exactly what we're going to do here today. Another question people ask me is, who cares about Java applets? Who cares if you can do DNS rebinding with Java applets? There's lots of other different technologies you can do DNS rebinding with, and we're going to talk about that. So some people say you can do DNS rebinding at the socket level with JavaScript. That's pretty impressive. Those people that are doing that are very smart. Some people say you can do it with Flash, which is true, and some people say you can do it with Live Connect. Well, there's some drawbacks to each one of these. The JavaScript stuff's very complicated. Once again, people who are way smarter than me are doing stuff like that. I can't replicate it. I'm sure some of you could, but I'm just not smart enough to do that.
We're talking about Kaminsky here, right?
Right.
Not everybody can do what he does.
Right, exactly. Flash, they do allow sockets. You can do DNS rebinding with sockets. It's a little limited in some of the ports that you can access. I think only ports over 1024, so it narrows it down just a little bit. And Live Connect, it actually only works in Firefox and other Gecko-based browsers, so that kind of eliminates a lot of your target area. And so a guy at Black Hat USA gave a talk on DNS rebinding, and he said, hey, I can do DNS rebinding with Java applets. It wasn't actually really truly Java applets. In reality, it was Live Connect. So it was somewhat limited to Firefox, but he showed a lot of really cool things. I don't want to take away from his research. So he showed a lot of really cool things, but there's a clear distinction that it wasn't truly Java applets. It was actually Live Connect. We came across some material in other places that just say, hey, you know what? Sun knows about this attack. They've known about it for actually 20 years when it was known as a Princeton attack, and some guy wrote a paper on it. That was like 20 years ago. Sun knows how to fix DNS pinning, DNS spoofing, DNS rebinding, anti-DNS pinning, whatever it is you want to call it. Sun's already got protections built into place to stop this kind of thing. And this is how they stop it. What they basically do is they pin an IP address to an applet, what they say basically for the life of the applet. It's actually really not true, but
yeah, it's actually not true.
And then we read this paper from these Princeton PhDs, the computer science PhD candidates, and they wrote a paper on DNS rebinding saying, hey, you know what? We can do a lot of really cool things with DNS rebinding. You can do it with Live Connect, you can do it with Flash, you can do it maybe with JavaScript. And then they threw in a paragraph here that said, hey, you know what? The current JVM, the way it is, the way it's made, is not vulnerable to DNS rebinding at all, just because of the DNS pinning mechanisms they have in place. So we see all this stuff, and naturally we see so many people saying you can't do it. So me and Nate decide that it doesn't, if it takes us our entire life, we're going to do it.
Of course you can.
Right.
I mean, You could do this, this wasn't even extremely complicated to do.
Right, exactly. It's very simple. There's some other reasons we want to use Java applets. Number one thing, sockets. Like every other technology that's vulnerable to DNS rebinding, you can use sockets, but this is probably a little bit more powerful. I think the most important thing is abstraction. So I don't know if any one of you ever tried to program a database connection, a JDBC connection to an Oracle database at the raw socket level. I've never done this. Unfortunately, I've never found a need to do this. I would think that it's pretty difficult. And if it's not difficult for you, I mean, hats off, I'll buy you a beer, but I'm going to guess that it's probably difficult for 99% of the people in this room. Programming things at the socket level involves a level of complexity that's going to basically take it away from your average, normal, everyday security researcher and hacker. And even if you do want to spend time in learning that and doing it, it's going to take a long time, even to do the most simple of executions or simple of events. The last thing is Java actually has I'm sure you guys know this, Java has a lot of libraries and classes that you can just kind of use because a lot of people use Java. So if you're dealing with some weird protocol or a protocol that's well known, more than likely there's a library or a class that you can use. You don't have to reinvent the wheel. And some specific examples of this is JDBC, SSL, and there's lots of others. The example that we're going to show you today is JDBC. And then the last thing that's really cool is you can actually remotely control an applet, which we're going to show you as well. So it's not just that you put your malicious payload or your payload onto a Java applet and let it execute, and then if things didn't work out the way you thought it would, then you're kind of screwed. In this case, you can actually remotely control the applet from 10,000 miles away, and you're accessing a device that's on someone's internal network.
And the big thing is how easy it is. We're not doing like what Kaminsky did, where we reinvent TCP and JavaScript.
Right,
That's
exactly.
Awesomely crazy, but we're not going to try that.
I'm not that smart.
We're
Right,
doing
exactly.
it much simpler.
Yeah. This is basically how the attack is set up. If you can see, there's the evil attacker in the bottom left-hand corner. That's Nate. It looks a lot like Nate. If you see his hair, it doesn't have a hat on. But then what we're going to use is we're going to use a cross-site scripted website. You don't have to use cross-site scripting. It's not a requirement in this, but we think it's kind of cool because cross-site scripting actually allows you to have that remote control over the applet that's going to be on someone's internal network. Of course, you're going to have your victim. In this case, the victim is actually sitting behind the firewall. And like I said before, a lot of times, 99%, port 80 HTTP traffic is going to be allowed through to and from over traversing the firewall. And then our target is not the victim because I thought cross-site scripting was cool. I thought owning client-side stuff was cool, but like my friend said, he prefers owning the server. So what we're going to do is we're going to actually use that victim's machine. We're going to put some malicious code onto it, well, so-called malicious code onto it, our payload, our Java applet, and then we're going to remotely control that applet and use that applet to actually access a JDBC or Oracle database, which is someplace on the internal network.
And I think one of the big things is think of the payload delivery here with cross-site scripting. We put this in like MySpace or something where everybody goes to it, and now everybody that visits that link is potentially having their internal network attacked. So if you don't have corporate protections on what kind of web pages your employees are viewing, things like that, or even if you do, this is still a very feasible attack.
Definitely. So basically it's going to work like this. The victim's going to go out to a cross-site website. That cross-site scripted website is going to hand over client-side control through cross-site scripting to an attacker, which we're going to show you. And then we're going to use the remote control from the attacker on the applet to access the Oracle database. That's just going to how it's going to work right there. And so just to let you know that this isn't some old version of Java or whatever, this actually works against the latest version of Java. Yes, we did tell Sun. Sun knows about this. It's going to be very, very difficult to fix. I don't think they're going to have it fixed out anytime soon. But I'm just letting you know that, we run the latest version, fully patched version of Java. It still applies in this case right here. If you're running an older version of Java, there's actually other scenarios that can happen that'll make this even worse. But if you're running an older version of Java, you might have other problems as well.
And this is IE7 as well that we're using.
Right, exactly. So here's a Java control panel. There's something that's very important as to how we pull this off. Now, if you look at the documentation, it says that the Java JVM is not vulnerable to DNS rebinding because of one thing. It says we pin the IP address to the applet for the life of the applet. That's not actually true. There's one small distinction. They actually pin the IP to the applet for the life of the JVM. And that's a small but very, very, very important distinction because you would think that the applet could not live past the JVM that spawns it. Well, there's actually a way. Java actually has a caching mechanism that they use to prevent destruction of their cached objects. So if you had a huge application and you didn't want the browser to handle that cache because everyone knows how to clear the browser cache, what you can actually do is use Java sticky cache. And you'll have a lot of different control. This is actually the Java sticky cache view right here. As you can see right now, it's empty. The way we set this thing up is that you go to a specific website through cross-site scripting or URL redirection or any other way that you want, and you basically load this HTML content. This is a request for the HTML content. More importantly, what you do is when the browser makes the request for the class file via the HTML content that you just served, you kick back a response like this. And the most important piece of the response, if you look up there, is the expires header. So in the response for the class file, in addition to sending the bytecode, you send the response header with an expires tag of whatever date you want. In this case, we put 2010. So that's not going to get cached by, well, it will get cached by the browser, but more importantly, what's going to happen is the Java JVM is going to cache this inside of its sticky cache. And so if someone closes the browser and decides to, because they've been surfing shady websites and they don't want their girlfriend to see what they're surfing, they decide to erase the cache that they have, the browser cache and all the history and that sort of stuff, the Java class file actually stays there. It stays there till whenever we want it to. In this case, it's going to stay there for almost 3 years. The other good thing is if we need to include something, let's say class is 12, we can do the same thing. So we serve up class is 12, and in the response, we just say, hey, expires sometime way in the future, 3 years or so. And so now, if you take a look at the Java sticky cache, you'll actually see that there's these items in here. And if you take a closer look, what happens is you see the name and you see the URL that it's coming from. Now this is a problem. This is probably where the DNS rebinding problem exists, because they keep track of where this applet came from, not from the IP address, which is where content is served from, but from the domain name. So obviously, you know, if there's a domain name mapping a relationship to the IP address, and you can change the IP address, that's the heart of this DNS rebinding issue right here. So Sun and the way they've implemented their Java caching policy and their sticky cache, basically they're keeping track of where these class files and these jar files are coming from the domain name. It seems like it's pretty solid. They keep track of it. They want the whole path. It's not just the domain. It has to be coming from the exact path that it was served from. It's case sensitive, which seems like it's a security feature, but could actually introduce other different things. But we'll probably talk about that later on, not today. Right. So, and then what's also important is there's a modified date, and then there's the expires date. So as you can see, it's expired. The expires date is 2010. So this class file and this jar file are going to stay in the Java sticky cache until 2010. The date and the time that we specify on the response that we send back, the HTTP response, is what the Java sticky cache is going to use for their thing. And then there's a version and there's a size. The version and the modified date actually come in are really handy if you ever want to upgrade your payload or upgrade your malicious applet that you're caching onto someone's local machine. So at this point, they've gone to our website, or they've been redirected in some way, or we've injected something in cross-site scripting into some page that someone's gone to, and we've cached these applets onto their local machine. So the next thing that we do is we change that binding that the class or the jar file is bound to. So we do that via something like dyn DNS. And all we do is we log into our dyn DNS. If you take a look at the new IP address, we have a internet IP address, an external IP address. All we do is we change that to an RFC 1918 address, which is an internal IP address. If you want like specifics about how to do DNS rebinding attacks, this is just a real quick run through. Just talk to that guy right over there, Martin Johns. He basically brought back DNS rebinding from the dead, and I think like a lot of people are surfing off of his work, but he's actually probably the pioneer who brought all this stuff back. So if you want to know how basic DNS rebinding works at its most basic level, just talk to that guy and he'll probably tell you everything you want to know. So,
there's good papers on it now too.
Yeah,
so.
Definitely. Okay, now here's where the tricky part comes in. So there's a couple different ways you can get, remember what I said before, the IP address is not pinned to the life of the applet, it's actually pinned to the life of the JVM. So what you basically have to do is you either have to destroy or close the JVM in some way, which drops the DNS pinning, or you have to start a new instance of the JVM, which they both share the same cache, but they'll both have different DNS pinnings, or you can load a different version of the JRE. And here's some steps on how you do each one of those. And we'll tell you some pros and cons with regards to each one of them. So the first thing is to close the browser. That obviously destroys the instance of the JVM. So this is probably the easiest way to do it, but it probably takes the most time, because you won't be able to do this in one straight shot. You're going to have to wait for your user to come back to your website or get cross-site scripted again and basically load your content again. The good thing is, I don't know if everyone is here for the HoneyNet project or the HoneyNet talk, is because the content's cached on your local machine, even if they take my evil server down, it doesn't matter, because the content is already on your machine. So once I've got it on your machine once, it's there. And then this attack remains valid till whatever date I specify, which is 2010 in this case. This is probably the most time-consuming way of doing it. The second way is to call an external Java-supported application. And the funny thing is that each instance of every different application actually spawns its own instance of the JVM. So if you have Mozilla Firefox and you have IE7 and you open them both up and you go to a page that has a Java applet, they'll actually both load two different instances of the JVM. And although they share the same cache, which is the foundation for both of them, they'll actually do different DNS pinning items because there are two instances of the JVM, because the IP address is not pinned to the life of the applet. The IP address is actually pinned to the life of the JVM. There are some URLs that or URIs that we were using. The only problem that we've encountered with using an external URI is every time we take a look at the external URI and how we load the Java JVM, we always find like a zero-day exploit with the other external URI.
If you guys have seen any of our latest exploits, the DEF CON talk that we did or our website, we've had a number of O-days for some of these URIs. And so like Billy said, every time we try starting to do something like this, we get distracted. But these URIs can all be used to do exactly what Billy's talking about, load a new JVM, and you'd be surprised by some of the stuff that's installed that can be exploited on your system through simple cross-site scripting. Exactly.
So the first time we did it through Firefox URL, and we found out there's remote command execution Firefox URL. Firefox patches it, we're like, oh, that sucks. Then we find out that we can do this through Navigator URL, remote command execution through Navigator URL. Mozilla, at the time I think it was Mozilla, they patched it, right?
No.
Anyways, it was patched.
I don't think the Navigator URL is
Navigator's not patched. And then we found out that Picasa actually has a built-in browser object that you can use to load the JVM as well. And then we found out there's some issues with Picasa where you could use this URI and you could steal images and content. And we told Google about that. He might talk to you about that after at the end.
We'll talk to you about that later, I think, at the end if we have time. That's our newest attack that we'll probably post the details on today.
Right. And the last way to do it is to basically load a different version of the JVM. Sun's actually trying to move away from this. They don't want people to do this. There's a lot of reasons why they don't want people to do this, mainly because they don't want people to use old exploits against older versions of the JVM that just happen to be installed on some machine. But they still do allow this. They still allow you to load it within three different you can load the most recent version of the JRE in each one of the different families. So this is kind of still possible, but Sun's actually moving away from this. So now we're going to move more into the attack, and we're going to show you a demo of how this would work, let's say in real life. But the important thing to know is that we're not dealing with sockets anymore. If you just look up there, this is just straight Java code. And so there's a couple things that are pretty important that you need to take note of on this page right here. If you look at the items that are at the bottom, so you'll see two variables down there. You'll see public string creds list, you'll see public string query data. That's important because if anyone in here is a Java programmer, you'll know that declaring things public is usually dangerous. And if I were to be doing a source code audit or source code review, and I saw that you were declaring everything public, I'd probably raise a flag and go, hey man, do you really need to be declaring this public? Because a lot of things can access it. Well, in this case, what we want to do is we want to make those items accessible. We want to make that variable accessible. So we declare it public. And we'll tell you a little bit why we want to do that in this case here. This is the actual method or function that we're going to be using. This is going to be probably the meat of the demonstration that we're going to be showing you in a couple minutes here. And this thing is basically just a function called run query. So if we take a closer look at this, I just declare this thing public, which like I said is bad, but I'm doing it for a specific reason in this case. And then what this method is basically going to allow is you just pass it a SQL string, and that's it. And it goes through, if it's connected to a database, it'll piggyback off that database connection. It'll run that SQL query. And then if you look back here, it'll just go ahead and get the result set, put it into a string builder, and then at the very end, it's going to pass that string builder to that public string that we had declared earlier, query data in this case. And then it's just going to end. Okay, this would be the HTML code that would be used to cache or call this applet right here. So if it's already cached on your machine, it would call it. You would use something like this. You wouldn't do width height 500, 200. You'd do something more like 1.1, which we're going to show you in the demo. So you can't even see the applet.
You can't see it happen.
Right, exactly. And then if you wanted to, let's just say, have the malicious payload inside the applet and just run that malicious payload and kind of ferry it off, you could do this via JavaScript functions. And so this is the way you would do it. And this is where those publicly declared methods and variables come into play once again. So what's allowed is you can actually use JavaScript to interact with an applet. I know some of you probably know this, but the JavaScript that's in the browser, when it's actually interacting with the applet, can only interact with certain things. And those are the things that you declare public. So if I have a method inside of a Java class that's cached on your machine and it's declared public, and a browser instance loads that class, the JavaScript on the browser can actually interact with the applet as long as that method's declared public. So I can actually pass variables, and I can pass different strings and that sort of stuff to methods if it's expecting it, and Java will recognize that and it'll support that and it'll execute that particular method. On the same level, if there's a variable that's declared public, JavaScript can also access that variable if it's declared public, once again. So if I have a Java applet that does some kind of malicious thing, feeds all the results into some public variable, and JavaScript can actually access that public variable and access the contents of that variable. And then once you've loaded it into a JavaScript object, you can basically push it offsite to wherever it is that you want it to go. Okay. The victim isn't going to see what's going on. In this case, we've coded our applet so it does system.out. So if the console is open, which you have to do, which is not the case by default, usually the console doesn't come open. But if the console is open, this is probably what the victim would see. If they're connected to a database, we're just printing the lines out to system.out. So it would just display in the console. What we're showing here is the applet actually can connect to a database, run a query, and then pull the result set back and put it into a publicly declared variable. And if we wanted to, we could actually just do an alert, the variable name and the variable value that's public in JavaScript, and actually push that content into a JavaScript object, which is what we're showing here, right here. So usually you see, cross-site scripting pulled off as alert XSS or alert HITB, and then they have this little alert box. In this case, what we're doing is alert document applet name dot variable name, and then that's going to push the content or the value of that publicly declared variable into the JavaScript object. So now, what we're going to show you, I think 2 slides from now, is a different way of doing this. We don't want just the content to be just served from the malicious applet and just to be run on its own. What we want to do is we want to remotely control that applet. We want to drive how that applet works. So we're going to build all of our attack functionality in this applet, and we're not going to kick any of it off. We're just going to have it sit there on your machine until you become cross-site scripted, and then we're going to remotely control which pieces of content, or which pieces that we want to execute, when we want it to execute. We're going to do this remotely. And the way we do this is we're going to do this via cross-site scripting. Now, the way to do this is basically to use script source. And I think people who are very familiar with cross-site scripting know how script source works. So basically what we're going to do is we're going to do a script source. I'm going to point it to a cross-site scripting proxy that I've written. What the cross-site scripting proxy is going to do is it's going to load up a couple different iframes. One iframe that the user can see, that's going to be 100%. That's the only thing they're going to be able to see. And it's going to load up a bunch of tiny iframes that the user will not be able to see. Well, those tiny iframes are actually my control channel, and they allow me to interact with the different browser instances. We're just going to give you, for those of you who are not familiar with remotely controlling cross-site scripting, we'll give you just a quick preview on how that works, and then we're just going to move into how you remotely control this Java applet. It's dynamic content. I can actually inject whatever I want to into the cross-site scripting proxy. That'll be executed in the victim's browser. This happens despite the fact that the applet's cached, because I can use any functionality that's cached inside the applet. Then, like I said before, there's JavaScript, Java interaction through the public methods and through the public variables. I'm going to show you how we're going to get that content back to the attacker, because it's not worth anything if we can't get it back to the attacker, right? And then I'm going to show you my cross-site scripting proxy that I wrote. I call it cross-site sniper. I like it. I think it's pretty cool.
Yeah, and so what we're going to have is we're going to have a framework for attacking your internal network through cross-site scripting. And keep in mind with Java, we could do anything we wanted to do. Telnet,
right, exactly.
Oracle, SSL, anything we want.
Any protocol that's supported by Java,
yes,
we can do it.
Maybe the only exception is some of the strange Windows protocols, which we may or may not be able to do.
Right, exactly. So let's go ahead and see if we can do this demo here. Okay, this is a pretty heavy demo, so.
Please keep that in mind.
Right.
Not everybody does demos with their presentations, but we'll give it a shot.
This is my cross-site scripting proxy, but what we're going to show you is what the victim would see if they fell victim to an attack like this. Can you switch over the screen for us, please?
Yeah, I'll play victim here today.
Okay, Nate's my victim. He's on an internal corporate network, and there's a database full of computer game codes that I want, and so I'm going to use his computer to attack the database. So he would just be surfing along, and he would go to his credit union website, which has a persistent cross-site scripting someplace inside.
Right, yeah, I want to post to the customer forum. I've got some problems with the site, so I go ahead and click on it, and it loads here, and I don't see anything. Yeah, but I've in fact,
no, give me 1 second.
I can close my browser again. That's what we had to do yesterday. In any case, I've effectively just been cross-site scripted here, and I'm not going to see anything from user interaction, right? I'm just going to continue to go about my thing.
Yeah, try it one more time.
Can we close it and try it again? Sorry guys, I have so much stuff installed on this machine from the URI stuff that we've been doing. It's not even working anymore. You can see my nice Google toolbar. Gotta love it. Did you get me?
Yeah, give me 1 second here. I might just have to run it locally on my machine real quick.
Yeah.
Let me just see if I've got what I need here. Okay, what I'm going to do is I think we're having problems with the just the interaction that we have between our two machines. So I'll just go ahead and run this locally, to tell you the truth. Okay, let me see if mine works. Okay, mine's working here. So you want to switch over back to my machine? I'll just run it all off my machine. Okay, this is basically what the victim would see. So they were basically on a credit union website, and they would go to a page that has a persistent cross-site scripting loaded inside the page. In this case, it's a customer forum, which is probably the most common place for persistent cross-site scripting exists, right? Well, what they didn't know is what's happened already is they've had a cached applet and a cached jar file inside their Java sticky cache. So if you take a really, really close look, actually you can't see it in here, but the only indication that you have really of what's going on is there's a little Java, little mud glass in the bottom right-hand corner. So, but, 1,000 miles away basically is me with my cross-site scripting proxy. And so if you look at the right-hand side there, what I've done is, like I said before, I've made it to where a bunch of iframes load. One iframe basically takes up the whole screen. So what the victim is seeing here is just the one iframe that's 100%, takes up 100% of the screen. The other iframes are very small, you can't see them, they're invisible. But those other iframes actually allow me to have that remote control over the content. So just as a very simple example, what we're gonna do is, I'm gonna go ahead and type a payload into here.
It's a bidirectional communications channel now. Basically, the proxy keeps saying to us, do you have a command for me to run? Every 5 to 10 seconds,
right.
Whatever we want to set it at. And we just say, no, or we say, yes, we want you to alert XSS. And then it goes ahead and does that.
Exactly. So if you didn't see what happened here, all I have to do is type JavaScript into my active payload box, and then every 10 seconds, like Nate said, the client's browser is going to pull to my machine and say, hey, do you have a JavaScript payload for me? And I'm going to say, yeah, I do. Go ahead and do alert XSS. Now, this is a typical function of a Java or XSS proxy. So you'll just be able to just inject JavaScript at will right here. So now I'm going to go ahead and take that out. Obviously, you wouldn't do that if you're attacking someone, right? So, but what I know is, I know that the victim has loaded some of my applets. So if you take a look at what's loaded up here, it's kind of difficult to see. Let me just do a magnify for you real quick. Okay. Let me pull this down. Okay, close this down. Well, can everyone see that up top? So basically what happens is, in the big frame that everyone can see, I've basically given that frame a name. And that frame is called my frame. And then my frame basically has a DOM object that's called document, which is the entire document of it. And what you can do is you can actually refer to the applet name, which is in this case attack applet. And then if I want to run a particular piece of functionality that's declared public inside that applet, I just call that particular piece of functionality. So the first piece that I'm going to run is something that's called default creds BF. So basically what this is it's going to connect to an Oracle database that's on some port someplace that you can do port scans as well. I'm just going to skip that part, but
that's already been covered.
Right.
Martin,
you can do it JavaScript, all that sort of stuff. But what I'm going to do is, we know where the database is located at on their internal network. That's pretty easy to do. So now what I'm going to do is I'm going to tell the applet to go ahead and make a connection to the Oracle database. But I don't know what the username and passwords are for the Oracle database. So what I have is a list of username and passwords that the applet's just going to try. So basically what I'm going to do is I'm going to use the victim's machine to do a brute force for creds against the Oracle database. And this is the way I would do it here. So let me copy this here. And this is all through JavaScript, so I just paste it in there. I wait for it to execute, which is about 10 seconds. Okay, so it's executed now. Now, that doesn't do me very good, right? I mean, I don't know what happened. So what I need to do is, what the applet's done for me actually is, it's done the brute force, or it's doing the brute force right now. What I need to do is get the results from that brute force and put it into a public variable, which my applet does. And so now all I need to do is grab the contents of that public variable and feed it back to my cross-site scripting proxy. And so that's what this line of code right here is going to do. So if you take a look at this guy right here, I've got a JavaScript function that's built into my XSS proxy that basically uses a post request. It's going to grab the contents of that publicly declared JavaScript or Java object or Java variable, and it's going to post it back to my cross-site scripting proxy. And I do that just like this. All I have to do is paste that in right here. Okay. And so I give it a couple seconds, it's loaded, and then the contents are over here in what I call sniper scope. So let me open this up real quick for you. Let's say in a notepad. So can you guys see that in the notepad right here? Let's see. Okay, so basically what it did is it went through a couple sets of credentials. The first set that it tried actually didn't work. It was a username of test and a password of test. And so I tried to connect to the Oracle database, and the Oracle database said, no way, man, that's not a valid username and password combination. So it kicked back an Oracle exception. So what I did is I had my applet say, go ahead and put this into the variable. I'm going to keep track of this. Go on to the next name. And so I put the next name in, which in this case was Scott Tiger. So all the Oracle gurus out there probably know that that's a default username and password for Oracle database. And after it tests the connection to see if it'll work with that, and if it does, it'll go ahead and tell me, hey, you know what, Scott Tiger works. It'll put it in that publicly declared Java object, which I can access via JavaScript. So at this point, the applet actually has an active connection to the database that's on someone's internal network via this Scott Tiger right here. If I wanted to, I could have a huge list of username and passwords, and I could go through each username and password until I enumerated, a bunch more to see which one had the best rights or the best, best privileges for my specific
instance. Yeah, we can go and steal the list from the Oracle auditing tools and just implement the entire thing right here, brute force the common password. I mean, we could even go as far as getting the permissions for those users as well if we wanted to do that.
Right, exactly. So the next thing that we're going to do is I showed you a piece of the code that's in the attack applet. Remember I showed you that method that was declared public? It was called run query. And remember, run query, all you need to do is feed it a SQL statement. So in this case, what we're going to do here is if you look up at the very top, I'm just going to feed it another piece of JavaScript. Once again, it's going to be parent, and then the my frame, which is the 100% frame that only the victim can see where the Java applet's loaded, document, and then there's the name of the Java applet that I have, the attack applet. And then I'm going to call the run query method right there, which was declared public. And all I'm going to do is just pass it whatever SQL statement that I want. So in this case, I'm going to pass it select table name or table underscore name and table space name from user tables. And if you want to, I can put any query that you want, and this will be executed against the backend database. Let me copy this guy here. I go to the cross-site scripting proxy. Let me clear these guys out so I can see what's going on. I just go ahead and paste that guy in. I wait about 10 seconds for the browser to query my cross-site scripting proxy again. There it goes. I go to the sniper scope. Let's see. I don't think it pulled over yet. Okay. So what's happened is the query's run, and the result set's stored in a publicly declared variable. So I need to get that variable back. Do that right there. Okay, wait a couple seconds, and then it's executed right there. So there's the results of the SQL query that I've run. So I'm running all this locally right now. The way the demo should have worked was this guy would be here someplace and inside the corporate network with the database someplace inside the corporate network, and I would be a million miles away outside the firewall running these queries against it. So like I said, you can run any query you want. It's not just, it's actually you can run anything against the Oracle database you want. So if you know advanced Oracle database hacking and such, you actually have a connection established to the Oracle database. So things like privilege escalation and such apply.
So just go back to like the Oracle auditing tools. What could we do? Well, I mean, for anybody that's used that, now that we're connected, if we can get a user with create library permissions, we can do that same DLL injection that they do to pull back the password hashes for that system. So, I mean, it's pretty crazy what we can do with this now from an internal perspective. And keep in mind, this is just attacking Oracle here, and we could be attacking anything we wanted to.
Right, I'll just run one more SQL query just to show you that I can type anything I want in here. So even if I wanted to do like a select star from user_tables. Okay, it's been executed. And all I have to do is just grab the contents of that publicly declared variable and ferry them back to my cross-site scripting proxy, which I think it just did. Yep, there it goes right there. So let me take this out. So there's the result set of another query right there, SQL query. Let me go back to this guy here.
So, some other ideas of what you could do with this. You could rewrite the way that Java handles sockets in such a way that it's much more like how C handles sockets, for instance. Maybe you implement the entire Metasploit framework now within a Java applet, and you just push your exploits across. Maybe you are good enough to write a class that will actually interact with the NetBIOS protocol in Windows. I mean, you could certainly try to do that. I don't know if it's actually been successfully done, but I'm sure there's some things you could do with that.
Right. We chose the JDBC connection with Oracle database because I think it's something that a lot of people understand can't be done very easily over sockets. But like Nate said, any protocol is basically vulnerable. All you need to do is just have the right Java classes and then just declare everything public, which is a poor secure coding practice, but we're doing it in a sense for attacking. Run the method that you want to use, push the result set back into a publicly declared variable, and then you can pull that variable into JavaScript space and push that out to wherever it is that you want it to go to. So we're going to take some quick questions on DNS rebinding with Java applets, and classes, and such. And then Nate will talk a little bit about Picasa.
So we can talk about our newest ODE that we're going to be releasing on our site today, which is for Picasa.
Right. So are there any questions, real quick? There are none.
There are no questions. I think we're supposed to give out some Panda software if anybody has a question.
Right.
But we didn't. Maybe not. We weren't given that. I don't know. Is it back there? Anybody with any question at all, you can have the free Panda software. Okay. Oh, we'll jump into that.
Yeah.
You ready then?
Well, what I'll do is for this stuff right here, this Java applet stuff, I'll post all this stuff on my site as well, and the slides will be available, I think, through the HITB website, right? So you'll be able to see some of the code, but the actual applet that I use and such, I'll put that on my website so you can take a look at it. It's very simple. Anyone that has a basic knowledge of Java can do it. So, and then Nate will tell you a little bit about Picasa.
Yeah, so, I don't know how many people have been looking at what we've been doing the last month or two, whatever it's been. We've had a lot of URI exploits that we've discovered, and people are familiar with URIs, I'm sure, in here. You have your standard ones, HTTP, FTP, Telnet, these kinds of things. We found a number of ODEs within those for command injection, stack overflows, all kinds of crazy things. The thing that we've been talking about the most that we think is probably going to be the coolest attack vector from that work is the functionality abuse, right? So all of these URIs are put on your system for some purpose. It may not be readily clear what that purpose is, but maybe you have a protocol like, AIM for the trillion exploits that we did. And maybe the AIM URI is used to actually send instant messages through a link. Like you would want to send someone an instant message, you would click on their AIM link and it would pop up already for you to type. Well, that's great and fine, but it also introduces a method for an attacker to communicate with installations on your machine through cross-site scripting. Because what's going to recognize URIs? Every browser out there, right? And other things that work like browsers, such as mail clients. So what we found, and first off, I love Google's Picasa, so please don't take it away from me. But it's a cool piece of software for editing photos. I don't know how many of you guys are familiar with it or use it. It's really slick. However, for whatever reason, they've decided to install a URI on your system called Picasa, // And what we've done with this, and if any of you are familiar with the site called Flickr, hopefully some of you guys know about Flickr, there is a method with the Picasa URI to import a button into Picasa so you can interact with other third-party applications. Good site on this is Picasa to Flickr. That's where we basically stole the information from to create this exploit.
But a lot of documentation with regards to the functionality that's exposed via the URIs is not available.
Right, in general, it's just not available. So you have to kind of do this on a black box perspective. Basically, what Picasa to Flickr does, it's a URI request that you click on from their site. And what it does is it says Picasa : import button question URL equals, right? And that URL equals parameter decides where it's going to get the code for that button from. The button's simply just XML. It's very simple. And what Picasa to Flickr does is they've created a button that allows you to click it from inside of Picasa and upload all of your photos to Flickr. Okay, so stay with me because this is kind of a multi-step attack using a couple different things. What we realized we could do is that one of the elements for this XML button is a target parameter. And that says where Picasa should post information so that you could do something like this. So we could have it point to our site if we wanted to, and that's what we did. Now, what Picasa does, just like a lot of Google's products, for whatever reason, and you may not even be aware of this, it actually starts a web server on your machine. Now, you can only access that web server from the local loopback, right? So maybe you're somewhat secure, you think. But in this case, what we did was we create a button. When you click that button, so it's a one-click step here to exploitation. When you click that button, it's going to actually send the URLs for the local machine for all of your images to our site. So let's step back a little bit. We're going to cross-site script you. We're going to force your browser to open Picasa : image, what's it called?
I think it's button image
or something like that. Button import, import button, I think is what it is. And it will actually pull XML content from a site of our choosing.
Cross-domain.
To get this button in. And if you then click on that button, Picasa is going to go through and says, these are all of the images and videos that I'll serve from this local loopback interface. And what the intent is that it will send that information to the third-party site. They'll then in turn send back an applet, a Java applet, that will say, hey, this is a Java applet, there's some security risks here. Do you want to go ahead and allow this to happen so we can upload your photos to Flickr? And of course the user's like, yeah, I want this to happen, so they do it. Well, in our case, we didn't want them to care whether this happened or not.
Right.
We didn't want them to even see that.
Right, exactly.
So what we did was, instead of loading back a Java applet, we load back a Flash application. And from all the work that Martin and some of our good friends have done on DNS rebinding, everybody knows now Flash has problems with DNS rebinding. So we load a Flash application, we DNS rebind through the same process that Billy talked about using like Dyn DNS, and we point it to your local host. So now what we have is we have control of a Flash application, and we know the content, we know all of the local URLs to access the content of your videos and images through Picasa. So we go ahead and get all of those, we pull those into URL stream objects. We have all of your data now within our Flash application. And we just simply make a cross-domain policy request back to our servers that says, hey, we're cool with allowing you to make cross-domain requests to our server. So now what we do is we then post all of your images back to our server. And we've effectively stolen all of your images and videos. We talked with some people about this when we were doing interviews for the URI stuff, and they were like, yeah, that's not a big deal. Talk some more about the command injections. I don't know. I mean, maybe you don't have sensitive images, but I'm pretty sure I don't want all my images and videos stolen. So.
Right. Google knows about this, and their patch is actually going to be coming out pretty soon, they told us.
And I think the method that they're going to take on it is it's a phishing attack. So they're going to try to put in some more warnings to prevent you from, because basically right now what happens is when you import this button, you just got to click the button and say, I want to do this.
And we control what the button label is.
We control what the button says.
Right.
We just say something like critical security updates to Picasa. You know, I think we can probably even make it Flash or something like that.
There's other instances that we didn't look at because we didn't have time. Maybe someone in here would love to look at this kind of stuff. But like Nate said, Picasa actually starts its own custom web browser on your machine. Like, I have a problem with that. I don't know if you have a problem with that.
I've got a big problem with it. And actually, the funny thing is, if you have Google Desktop, it does the same. It's probably well known to a lot of people now. Coolest thing about that, it starts it on port 4664. Look on your phone. 4664 is GOOGLE. G.
Right.
Goog.
The other thing that's kind of scary also is Picasa actually has a custom web browser built into it. And so anytime you see custom web browser stuff, it usually means that they took a web browser object and stripped some protections off of it. And so instead of loading a Flash object like Nate just talked about that's going to steal all your data that's basically supported by Picasa, you could also throw a client-side script in there as well.
Right.
And so depending on the protections of that browser mechanism.
And who knows what this browser mechanism is, right? Maybe it's the simple .NET class that allows you to just interact with IE through it. We don't know because, Picasa is not open source. But think about this, right? All of the protections that are in your browsers that have been worked so hard on by like Windows and the people at Microsoft and the people at Mozilla and all the browsers, can you claim that those are in this custom-made browser? I kind of doubt it. And in fact, the custom-made browser in Picasa doesn't even show you the URL bar. So you have no idea where you're pulling this information in from. So it's a pretty scary attack vector. We've got a question?
Well, yeah, this kind of attack will only work on the browser which is having JavaScript or Java enabled. Is there any way that this kind of attack should be enable the browser which is disabled?
Yeah,
Java?
actually what you said is not
and
true.
And the next question, how can you make the browser more secure? Even though we have some products from McAfee such as Site Advisor, Friend Protect, and Netcraft, it seems. So these things are not working enough.
True. Are you asking about DNS rebinding, or are you asking about the Picasa issue?
Let's go one question at a time.
Yeah.
So
go with the first one, please.
Okay. For the DNS rebinding issue, I actually don't think it's a browser issue.
It's not.
Browsers have their own pinning mechanisms, which I think the browser manufacturers can work on to make sure that their browser doesn't fall victim to pinning issues. But I think it's more of a DNS issue. And it's more of a fact that, let's say, now you're dealing with DNS pinning mechanisms for a lot of different applications. So the browser's got its own DNS pinning mechanism, and now Java has its own DNS pinning mechanism, and Flash has its own DNS pinning mechanism. So the browser's not going to be able to stop some other application from doing DNS pinning the way it thinks that DNS pinning should be done. So I think it's going to be difficult for a browser to fix that. What's more important is to realize that you're accepting, I think Martin talked about this, you're accepting a DNS entry that points to an RFC 1918 address from an external entity. So whenever you see that, that should be a red flag going off saying, why is this external DNS reference referring to an internal host on my internal network?
That's probably actually the best way, and kudos to Martin on it, that I've heard to fix it, is now you're preventing the whatever application it is, browser, Flash, Java applets, whatever it might be, you're preventing it from getting repinned to an RFC 1918 address. So you can't, at the very least, you can't attack internal systems. That doesn't stop someone from taking control of your machine and attacking remote systems. But
that's a different ball. I think
it's a different thing, and I think I'm much more concerned about attacking internal resources.
Okay. So there is no possible way to enable JavaScript on the client.
Well, you can't control the specific. Well, you can control the specific.
We have different
mechanisms.
issues with the BHOs. We can exploit it.
What's that?
Especially for BHOs. I'm talking about the browser helper objects. Especially for the IE.
You can disable Java. You can say, hey, I don't want Java to run on my
You
machine,
could
which is
turn
what
off
I do.
Java applets altogether.
No, I'm talking about, is there any way that we can enable it? Since it's disabled, is there any way that we can enable it from our exploit?
I'm not sure.
following the
Yeah, I'm not
question.
sure what the question is.
Enable the JavaScript, break into the security layers.
Okay. Well,
Yeah.
there's two different things. If you want the remote execution and you want to ferry the results back, you're going to need some way of ferrying it back. So it doesn't have to be JavaScript. If you declare it public, you can actually probably use Flash to do the same thing. But JavaScript makes it a lot more easier to remotely control. And the other issue, like what Nate's talking about, is actually a URI issue. So it doesn't require JavaScript. It doesn't require client-side scripting. Something as simple as a redirect. You click on a link or something like that, and it just redirects you. Let's say you have JavaScript turned off. The URI is still going to be supported.
Right.
There's other mechanisms to help protect against URI exploitation. I think Firefox has a pretty good one where you load an external URI that's not specifically defined inside their config, and then a warning is popped up saying, hey, you're about to run this URI. Are you sure you want to do this?
Right.
That's one way of handling it. And the other way of handling it is the application developer, when they expose the URI, need to realize that the attack surface for their application has just increased exponentially.
I think it's more about education. I mean, when you think about it, is there any real reason why you really want Picasa to have a URI in your system.
Right. Why should someone
Can't I just
remotely,
go and download an
Right.
installation file for the button if I really want it that bad?
why should someone remotely be able to kick off an instance of Picasa and then control functionality that Picasa is going to do? That's probably the big question that application developers should ask themselves when they expose a URI.
Thank you very much.
Yeah.
We got a couple seconds here.
Yeah, any other questions at all?
Anyone else? Bueller.
All right, so for anyone that wants some details, I know I kind of breezed through a kind of complicated attack here. We're going to post tonight on our site, which is xs-sniper.com, and I'll post all the glorified details of it. Eventually, we'll probably release the actual flash code and things like that, but I can't be bothered with that tonight because I'm planning on going to the after party, and I'll probably not be able to do that after the after party. So,
Okay.
Yeah, if you have any other questions, just catch up with us outside.
yeah, we'll be around. So,
You may want to give this to the guy who asked the question.
yeah, who asked the question?
Okay, well,
Who asked the question?
just now somebody asked a question.
You want your Panda
Yeah,
internet
and,
security?
Yeah,
Yeah, go ahead.
yeah. You won by default. Okay, thank you very much. Then. So, well, there's a tea break at the right now, so please come back by in for 15 minutes.